This is the additional maths past paper 2022, and we're looking at question 15. So this question is talking about y equals sine 2x and from values of 0 to 360. And what we're going to have to do is squish the graph. Okay, so the reason why we're squishing it is because we're looking at something where the angle is producing it at a quicker rate because it's technically worth twice the amount it actually says it is. So where the angle would be 45, we're actually putting the value in as if it was 90 and so on. So if we think about the normal sine graph starts at 0, okay, and it would do a large loop and it would go at 180. Now the problem, because it's now sine 2x, we're going to get that result happening at 90 degrees because 90 times 2 will give us 180, so we'll be back down to 0. So at every point here, we're going to see a change happening. Now with the sine graph, it lifts up to 1 at 90 degrees here. So this time it's happening around about 45. So we're going to cut right in the middle. And the same here. So if I do -1, there we go, as best I can, it's going to cut down by here. And we're going to make that wave happening. And up again, and down again. Now, it is one then curve going through. Obviously, this is a little bit difficult for me to do on here, but I will try my best. So, going through and try and make it a smooth curve, not as jolty as mine is. There we go, up to 360. So that's the first 2 marks. Now, the second question, I'm going to change my colour. It says, find all the solutions for sine 2x equals 0.47. So we think about 0.47, it's happening around about by here, isn't it? So I'm just going to put a little dot for 0.47. Wow, that was my best bet. So I know it's going to happen by here, it's happening by there. I just give myself a little marker so I know what values I'm looking for, because it's saying that I need to give all the solutions from 0 to 360, and now I know I need 4. So straight away, I'm not going to be panicking. First thing I'm going to do in my calculator is do sine to the minus 1, 0.47. And that's going to give me 28.03, blah, 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 blah. But remember what I said earlier is this is currently what has happened is at a faster rate. So when the angle we originally think is going to be, that's actually worth 2x. And we want to find the solutions for x. We're going to divide that by 2, which gives us 14. It's the nearest degree, so I can leave that as 14. Oh, my bad. Let me just raise that out. Pen. That's 28.03. Then x equals 14, nearest degree. There you go. So all the values. So if this one is 14 degrees, so I'm just going to write it by here. So x equals 14. Now, remember they're symmetrical, so it goes 14 inwards, so then 90 take away 14 is our next one, which is 76 degrees. Now, the next one happens after 180, so we're going to add on 14, which gives you 194. And the last one that we got is going to be taken away from 270, so 270 take away 14, which gives us 256 degrees. And there we go. That's all of the marks for this one. So let's check it out. So the general sine curve intersecting at the x angle is 0, 0, 90, 0. Yep, fab. That gives us 1 mark. And the correct curve with 1 and -1. There we go. So just making sure that we got a clear curve, not straight at turning points. There we go. That's what we did. And the maximum should be between 0, 90 and 180 and 270. So that means the highest points Okay, so then the next one is do not reward B2 or B1 for incorrect answers. So we need to make sure, fab. Oh, there we go. So we had to show it by doing 2x is 28.7, leading to x is 14, which is what we've shown. If we had done it divided by 2 straight away, we would have similarly got an answer, but that's not the correct way of doing it. You had to find out what 2x is and then divide by 2. Okay, so just be mindful of that. Work it out first, write it down, then divide by 2. And there you go. Hopefully that helps.